Greetings, the Astro 30 here yet again with a brand new video for you on a rather overcast morning. Sitting on the desk here today I've got a PowerTech MP3090. Jaycar used to sell these for around the $200 mark, maybe $250, I can't remember offhand, which is a switching mode DC regulated power supply, and Jaycar have now discontinued this model in favour of the MP3091. Now this is a 3 volt to 15 volt power supply, 40 amps continuous. Now for that voltage it kind of makes it a little bit useless as a general supply, but you could use it as a communication supply for, like, you know, ham radio, 2 meter transmitter, whatever, to give you a 13.8 regulated continuous voltage. It has large voltage and amp meters, digital ones on the front, overload LED, and the voltage pot. Now this does have an issue with its IEC socket, or either that or its plug not making a decent connection on the socket. So when I initially tested it out, it wouldn't even turn on. And then when I did get it to turn on, as soon as I started cranking the voltage up, it just turned straight back off again. So it turns out to be the plug's a little bit dicky. Now I was given this power supply. Well, actually, he said to me, "Do you have a use for this?" I said, "Yes, possibly." And then he handed it to me, but he didn't actually specify whether I could have it. Anyway, so with the advice of EEV blog, we're not going to plug it in, we're going to take it apart and have a look inside. And yep, this is what this power supply's intended purpose was. I've just noticed on the bottom side of the unit as I was taking the screws out, it's got this selector switch here. And it says, warning, if 13.8 volt is selected, the front panel voltage control is disabled, fixed 13.8 volt. So it is indeed designed mainly as a communications power supply. Right, so all the million screws are out. Let's pop the, no they're not, I've missed one. I ended up missing it because I ended up turning it over to show the bottom to the camera to show you that switch. And forgot to take the screw out. Right, let's try that again. I don't know if something was rattling around or not. And there we are. Ooh, in like Flynn. So there's the main PCB. You can see 2 large filter caps here. A humongous coil is back here which you can't see. It's got a fan at the back. And these look like chokes. I'm going to assume they're chokes. Turning it around the other way, look at the size of that humongous inductor. And this looks like maybe part of the current shunt sensing circuitry for monitoring constant current. There is a couple of adjustment potentiometers there, but it doesn't actually say what they're for. So it's best and probably not to mess around with them. Over here are 2 large rectifier diodes, and on the second heat sink there where it's got the warning mark, those are 2 large transistors. That'd be the output transistors. And there's another set over here. So they've got 4 transistors in the output stage, and at the moment I have no idea what they are because there's stuff in the way, so I can't even get a good look at a number or anything. I'll see if I can get a magnifying glass somewhere near it to have a good look. Now, unfortunately, nah, there's just too much stuff in the way. I can't get a good angle to look at it. I'm not going to pull them out to just see what they are. There's the back of the meter display board, and as we can see there's 2 potentiometers here. They're for obviously calibrating the meter, or meters. They've got a separate circuit board over here for the voltage pot, and really that blue wire is really badly put in there, but anyway. There's no identifying marks on this thing anywhere as to say where it was made. The back panel just says information about the replacement fuse and how much it draws in current from the wall, which is 3.3 amps. 3 volt 15 volt DC 40 amp output. It's using a 5 amp L250 volt fuse for indoor use only, and its serial number, but it doesn't say where it's made, most likely China. Now there's the power switch at the front, and if we follow that, that goes back into this shielded box over here. I don't know what's under that box. Maybe a soft start circuit for the power supply. I mean, I can always unscrew the two little nuts and bolts there and see what's under it. And the other side of the box comes out into this X2 rated large 250 volt capacitor, which is 1.0k. That's a 1 microfarad. It's got to be, there can't be anything else. I could measure it with a meter, I suppose. Let's see if this little meter, if I can get in there, will measure the capacitance. There is a resistor across it. The thing is unplugged and hasn't been actually powered up for days. So I'll see if I can get that to touch on there. Maybe that wire's in the way. There we go. 1.1 microfarad. So yeah, it's a 1 microfarad X2 class rated capacitor. So there we go. All that effort I went through to deal with the Loctite on those nuts, yeah, that proved absolutely nothing. It's a sealed or soldered box. I'm not going to unsolder that to see what's on the other side of it. I don't think it's really worth the effort. Alright, I'm going to put that back together. That used to be a shiny piece of metal, now it's all tarnished. Alright, I tried to get the main PCB out to have a look at the underside of it, but these large, thick copper wires that go to these chokes just won't allow it to move around without taking the chokes out, and yeah, I can't be bothered. At the very heart of the power supply, they're using a TL494CN, which is a switch mode pulse width modulator IC. That's the main control IC there. And down here is a TC4069UBP, which is a hex inverter IC. There's another IC buried over here, buried right down under all these wires. This is an LM324N, which is a quad high frequency op amp. So those are all the ICs that I can see that are in this unit. Oh wait, no, there's one more. Right there, it's an MC33262P, which is a power factor controller IC. Okay, so now I've done its exploratory examination. Let's plug it in and see what it does. Now, word of warning, this power supply is open. There are dangerous voltages inside this. It's never a good idea to operate a power supply with the lid off unless you know what you're doing. Do not come into any contact with any of these heat sinks whilst the lid is off, or actually any component whilst it's working, because you could be in for a very nasty shock and a bad day. I'm going to have to fix those screws on that power board. Now, well, it turned on. Now, currently it's saying 2.8 volts, so yeah, that's its minimum. And that's its maximum. So maybe I should put a load on the output and see what kind of current draw we get. So this thing comes with the crappiest clip leads, but yeah, it is what it is. Alright, I've got a 1 ohm resistor across the load here, and we're getting 2.5 amps into it, which as you increase goes up, but I don't want to do that too long because it will cook that resistor. So we can see that at 2.8 volt into a 1 ohm load we're getting 2.5 amps, so it is pretty close on its current, but I don't think it's quite right. That's only just barely warm. Okay, so you can adjust the current, but you've got to get a screwdriver in there somehow without coming into contact with anything else, so it probably might not be a good idea. I mean, it doesn't have to be perfectly accurate. We're about probably, I don't know, about 300 mA out, and that resistor's getting nice and warm, but we know it can draw current or produce current. It does take a while for it to, well, not when it's loaded, but it does take a while unloaded to turn off. Alright, so what I'm going to do is I'm going to switch it into the 13.8 volt range. I've put the lid back on because I don't need to be inside it anymore. So I'm just going to plug this thing back in and turn it on. And as we can see, we're getting, well, we were getting 13.7. It's this IEC connector and it's just done again. Let me eliminate that factor. I'm going to go grab a spare IEC cable. I'll fix you, you piltdown ponce. I've got another IEC connector. I don't like this plug anyway. It's very stiff to get in and out of the power socket. So plug this one in. That's a bit better. There we go. And that's a much more positive fit in the back of the power supply. So yeah, we got 13.7 volt there. And if I connect my load up, we should get around about 13 amps coming out of it. 11.5, and that resistor was starting to get to the point of destroying itself. Okay. And as we can see, that voltage pot now no longer does anything, which is kind of a loose pot too. It's not very, it's not very good. Alright, so we should be able to turn this over, switch it back into normal. As we can see, we're now down at 2.8 volt and it increases to 15.6. Yay! It's a working power supply now that I've changed the power cable. Does need a bit of a clean up. Could probably, I don't know what that is. It looks like paint. It's not a chip. Well, it does need a clean up. And what am I going to use it for? Well, I don't know, but if I need something that's as low as 3 or 4 volts or something, I suppose I could use it for that. But for my purposes, it's generally kind of useless. Well, it's not really useless, but I don't have a use really for a high current, low voltage supply. However, I might find a use for it. Anyway, I'm going to leave this video here. If you found it interesting, I'm going to encourage you to go down below and rate, comment and subscribe. And you can also follow me on Facebook or become a Patreon member for as little as $1 a month. And remember guys, I am wanting to try and get to 2,000 subscribers by the end of this month, August. So I'll do a special AMA video in September. So you've got that to look forward to. I know this video wasn't really all that interesting, but it is what it is. Anyway, this is Yastro30 saying see ya, have a great day, I'll see you in the next video. I've run out of isopropyl alcohol to clean stuff with.